All right, so for this next concept, it's really easy to understand. Well, we're going to need a couple of props. Okay. So all an angle is two rays with a common endpoint, right? And as those rays start to go in different directions, I start to form an angle between the two rays, right? All an angle is. Okay? Angle, side. Make sure we make that clear again, guys. Right, Tori? Angle between the lines. Side is the line. Okay? What I want you guys to notice is I want you, as this angle gets bigger, I want you to look at the distance between the endpoints. Okay? We call that the opposite side of the triangle. Here's my angle, opposite, away from, over here. So as that angle gets bigger, what happens to the distance? It's farther. So talk to me then about relativity here. If an angle is really small, what can you tell me about the distance on the opposite side? They're not equal. They're closer. Okay. So a smaller angle makes a shorter side. Does that make sense? Okay. A larger angle is going to have a longer side. Guys, when we look at a triangle, we can judge the relative sizes of angles and sides. I might not be able to tell you exactly what the angle is, but I can put them in order of rank from smallest to biggest. So when we look at this, and we look at the triangle angle inequality, what it basically says is that my smallest angle will be opposite of the shortest side. Write that down. The smallest angle is opposite of the shortest side. Away from. On the other side of the triangle. Yeah. So the smallest angle is opposite of the shortest side. So if we look down here at triangle DEF, and our instructions are to put the angles in increasing order, which means to do what? Smallest to biggest. So I need to find my smallest angle. So Patrick, according to the definition, where would I find my smallest angle? What's the wording that we use for that? Well, that's what would be in this problem. Read the board. Where would I find the smallest angle? Opposite. Okay, there we go. So we're looking at triangle DEF. Where's our shortest side? So right here's my shortest side. So the opposite angle of that. So Keenan, imagine taking a line and going toward an angle. What angle do I end up at? D. Okay. So my smallest angle is D. So what would be my next smallest angle? And how do you know that? Yeah, because A would be the next shortest side. Okay. So then F. So therefore my largest angle is so that's my largest angle. Now guys, with this particular problem, I'm not asking you guys to find the angle measures. I just want you to tell me what will be the relative sizes. Which one's going to be bigger than the other. Okay. Now the next diagram is a little hard to do. What you need to do is kind of refer these back to the same triangle. So I want to compare angle R to angle VSU. Again, guys, let's kind of show us here. So we got angle R and angle VSU. I want to compare these, I need to be able to compare them within the same triangle. So what triangle do you think we really need to focus our attention on? URS? Okay. So URS. Okay, so now if I want to compare them, basically I want to say, okay, which one's bigger, R or VSU? Well, look at the opposite side of R. So the opposite side of R is 35. What's the opposite side of VSU? 24. So which angle is bigger? So R. We would say that R is bigger than angle VSU. Okay, does that make sense? Okay, do we need any clarification on this concept? Okay. Now guys, the absolute reverse of this is also true. So where would I find my shortest side? Okay, just in general. Opposite of